The Science Hub Escape B. Part 3. Neutralization Reactions and Salts. Imagine two superheroes who team up to save the day. One has fiery powers and the other controls ice. They're total opposites, but together they create balance. That's just like what happens in a neutralization reaction. When an acid and an alkali are added together, they react to form a salt and water. The formation of water makes it a neutralization reaction. Examples of neutralization reactions. Antacids are used to relieve indigestion. Farmers add lime to their soil when it is too acidic. Hair relaxers are alkaline, and so the neutralizing shampoo used is acidic. Toothpastes are alkaline, so that they could neutralize the acid formed from the bacteria on the teeth. Salts are present around us. There are many different types of salts: chlorides, nitrates, sulfates, carbonates, and phosphates. They also come in many different colors. A salt is a chemical compound formed when the hydrogen ion of an acid is replaced by a metal ion or another positive ion. They are usually crystalline solids and can be soluble or insoluble in water. They conduct electricity when dissolved in water. Some examples of salts are sodium chloride, magnesium sulfate, calcium carbonate, and ammonium nitrate. We use table salt, sodium chloride, to make our food taste good. We also taste it when we take a dip within the ocean. There are other salts that are safe and even beneficial for consumption in small amounts. However, not all salts are safe to eat because some can be toxic or harmful to the body. Other edible salts are potassium chloride, magnesium sulfate, calcium salts, and sodium bicarbonate. Potassium chloride is sometimes used as a salt substitute for people needing to reduce sodium intake. It helps with muscle function and maintaining electrolyte balance. Magnesium sulfate is commonly referred to as Epsom salts. It is sometimes used as a laxative or to replenish magnesium levels. Calcium carbonate and calcium chloride are added to some foods to boost calcium intake. Sodium bicarbonate is known as baking soda. It is used in cooking and baking and can be consumed in small quantities. Reactions that produce salt. There are various ways of making salts. Acid plus alkaline to give salt plus water. Acid plus a metal to give you salt plus hydrogen gas. And acid plus carbonate to give salt plus carbon dioxide plus water. Acid plus metal oxide to give salt plus water, and acid plus hydrogen carbonate to give salt plus carbon dioxide plus water. Here is an acid and alkali reaction map. The type of salt formed always corresponds to the type of acid used. So, if hydrochloric acid is used, the type of salt formed will be a chloride. If sulfuric acid is used, the type of salt formed will be a sulfate. If nitric acid is used, the type of salt formed will be a nitrate. And if phosphoric acid is used, the type of salt formed will be a phosphate. Here are some examples of reactions with hydrochloric acid to produce salt. So, if you have the acid hydrochloric acid plus an alkaline such as sodium hydroxide, you get sodium chloride plus water. If you have hydrochloric acid plus the metal sodium alone, you get sodium chloride plus hydrogen gas. And if you have hydrochloric acid plus sodium carbonate, you get sodium chloride, carbon dioxide, and water. So all you have to do is follow these instructions and then you'll be able to get your outcomes correct. Here we have hydrochloric acid reacting with sodium oxide to give you sodium chloride plus water. And then we have hydrochloric acid plus sodium hydrogen carbonate to give us sodium chloride plus carbon dioxide plus water. Simply follow the information above to get your answers. So now we're introducing another type of acid with the same reagents that we use for hydrochloric acid. So here goes. Sulfuric acid plus sodium hydroxide gives sodium sulfate plus water. Sulfuric acid plus a metal like sodium will give us sodium sulfate plus hydrogen gas. Then we have sulfuric acid plus sodium carbonate, which gives us sodium sulfate plus carbon dioxide plus water. Sulfuric acid plus sodium oxide gives you sodium sulfate plus water, and sulfuric acid plus sodium hydrogen carbonate gives sodium sulfate plus carbon dioxide plus water. And now we have another acid, which is nitric acid, with the same types of reagents. Nitric acid plus sodium hydroxide gives sodium nitrate plus water. Then we have nitric acid plus sodium giving sodium nitrate plus hydrogen gas. Then we have nitric acid plus sodium carbonate to give sodium nitrate plus carbon dioxide plus water. Nitric acid plus sodium oxide gives sodium nitrate plus water, and the nitric acid plus sodium hydrogen carbonate gives sodium nitrate plus carbon dioxide plus water. And finally we have phosphoric acid replacing nitric acid, and we get sodium hydroxide plus the phosphoric acid to give sodium phosphate plus water, phosphoric acid plus sodium to give sodium phosphate plus hydrogen gas, phosphoric acid plus sodium carbonate to give sodium phosphate plus carbon dioxide plus water. Now we have phosphoric acid plus sodium oxide to produce sodium phosphate plus water, and then phosphoric acid plus sodium hydrogen carbonate to produce sodium phosphate plus carbon dioxide plus water. Just a note, whenever you react an acid with any carbonate, you'll always get carbon dioxide and water plus a salt. Whenever you react an acid and an alkaline plus an acid and a metal oxide, you'll always get a salt plus water. So maybe you can use that to help you along the way. Comprehension. What is a neutralization reaction? And 2. A bee sting can be neutralized with baking soda, while a wasp sting can be neutralized with vinegar. What does this say about the nature of each insect's sting? Great job. A salt and the water are produced when an acid and an alkali react. It is a neutralization reaction because water is produced. Well, from this information, a bee sting is acidic, while a wasp's sting is alkaline. Complete the following equations. So take your time and fill it out. You can always go back into the video to seek help. Best wishes! Congratulations if you got everything correct. So an acid plus an alkali will always give you a salt plus water. An acid plus a metal will always give you a salt plus hydrogen gas. An acid plus a carbonate will give you a salt plus carbon dioxide plus water. An acid plus metal oxide will give you a salt plus water. And acid plus a hydrogen carbonate will give you a salt plus water plus carbon dioxide. Again, note that an acid plus a carbonate, any carbonate will give you salt, carbon dioxide plus water. As you can see in C and E, and you recognize that A and D also match. An acid plus an alkali and an acid plus a metal oxide will always give you salt plus water. Make sure you take note of these similarities. Good job. Okay, so it says here fill in the table with the correct answers. So we have the name of the acid and the type of salt formed, and then you're supposed to fill in all the missing blanks. So good luck. Very good. So if you have a hydrochloric acid, the type of salt formed will be chloride salt. A sulfate comes from sulfuric acid, and nitrate will come from nitric acid. And from phosphoric acid, you get a phosphate salt. Comprehension. Complete the following equations. So try these equations. Please note that the acids are different, so are the types of metals used, and so the types of reagents used. So be careful. Make sure you remember the map or go back in time, look at the map and match back to get your answers. Alright, best wishes. See you on the flip side. And great job if you got these answers. So if we have nitric acid plus sodium hydroxide, we see that sodium nitrate is formed plus water. So all you have to do is to note which one is the metal, and in this case sodium is the metal, and it's going to form a salt, a nitrate salt. And since we have an acid plus an alkali, we're gonna have a salt plus water. And then again here we have sulfuric acid plus magnesium. So in this case, if we look back at our maps, we see that we have an acid plus a metal, and from that you should get a salt plus hydrogen gas. And here we have magnesium sulfate, and the salt is a sulfate plus hydrogen gas. Then we have hydrochloric acid plus calcium carbonate. Once you have a carbonate, you know you're going to get carbon dioxide and water coming off. And since we have hydrochloric acid, we know our salt is going to be a chloride and our metal will be calcium. Okay, so we have calcium chloride as the salt plus carbon dioxide plus water. Here we have phosphoric acid plus magnesium oxide. So in this case, we now have an acid plus a metal oxide. So we know we're going to get a salt plus water. And we also know the type of salt we're going to get, which will be a phosphate salt. And since we know that the metal here is magnesium, we have magnesium phosphate being formed plus that water. So we just have to know what we are dealing with. And now in the last one, we have nitric acid plus magnesium hydrogen carbonate. Once you see the word carbonate there, you know you're going to have carbon dioxide plus water. We look at our acid, it's nitric, so our salt will be a nitrate. And we look for our metal will be magnesium nitrate. Alright, if you got this correct, great job everyone. You have achieved platinum status. See you around for the next topic, which will be, I don't know, just wait and see. See you around for the next topic. Bye.